Okay, hi everyone. This is intended to be a video that's a follow-up to what we did in class with tangrams in Math 304. So I was talking about similar figures and scale factors. And I was using right isosceles triangles. So again, triangles are right isosceles triangle if it's got a right angle, like these, and if two of the three sides are the same length. Okay, so notice all of these are right isosceles triangles. And notice that these two angles are the same. So this is 90, and these two angles are both 45. So in a right isosceles triangle, you've got right 90, 45, 45, 90, 45, 45. So by angle, 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 they're all similar. That's the similarity thing. And what similar means is corresponding angles have to be the same, pairwise, and corresponding sides have to have the same ratio of length, and that's what we call the scale factor. So if you're scaling from a small one to a bigger one, the scale factor is going to be bigger than 1. If you're scaling from a big one to a small one, the scale factor is going to be less than 1. That hopefully makes sense. So first I want to sort of think about what would be the scale factor if we're going from this one here down to this one here. Okay, so what's the, and a lot of times we'll call it similar triangles and linear scale factor. So again, a lot of times we'll just call it scale factor, but the more technical, precise thing is to say linear scale factor, because it's how much each length is multiplied by, or the ratio. Okay, so notice here, if this has length 1 and 1, then this one here has length 2 and 2. And in fact, if we knew the Pythagorean theorem, this guy here has length square root of 2. And this one here, it has length square root of 2 plus another square root of 2. This has length 2 square root of 2. So hopefully you can see each of the sides have been multiplied by 2. So the scale factor S is 2. Okay, scale factor S is 2. One thing to notice when you have scale factor 2 is you can kind of chop this guy up into 4 of the original triangles. This one's sort of spun around, but 1, 2, 3, there's sort of 4 copies of this triangle in this triangle. Okay, now let's try this one here. And I'm going to do a slightly different way that we did in class. In class, I made an argument based on area. Now I want to make a more direct argument based on the lengths of the sides. So this side here, the hypotenuse, has side length 2. And notice here that the hypotenuse here, square root of 2, that's the side length here. So each of these sides has square root of 2. Again, why do I know it's square root of 2? Is think of it as part of a right triangle. 1 squared plus 1 squared equals that squared. So 1 plus 1 is 2. So 2 equals this thing squared. So this thing equals square root of 2. Okay. So notice here that the side length 1 corresponds to side length square root of 2. Here, side length 1 corresponds to side length square root of 2. So it's being times by square root of 2. So S equals square root of 2. If you actually did the measurement, let me try here. So this one here, I tried this in class, But if you're trying to do a more direct measurement, this is about 13 millimeters. And this is about, what, 18 millimeters? So if you did 18 divided by 13, it's about 1.4, something like that. Anyways, this is roughly 1.4. And what's interesting here is, notice this guy is 2 copies of that. Right, if I split it up. So in this case, the area is being doubled. In this case, the area is being quadrupled. The linear scale factor are 2 and square root of 2. Okay, so how about from this one to this big one here? What's the scale factor there? Well, we can do the same thing. This has hypotenuse 1, 2, 3, 4. And the side lengths are square root of 2 and another square root of 2. They're 2 square roots of 2. Okay, so the side length 1 is corresponding to side length 2 square root of 2. So S is 2 square root of 2. So if you have a side 1, then you can directly, what it corresponds to is going to be your scale length. Notice if I do the other one, square root of 2 corresponding to 4, I would have to do the calculation 4 divided by square root of 2. And that calculation would be, you have to multiply both sides by square root of 2 over square root of 2, and you get 4 square root of 2 over 2, so you get 2 square roots of 2. Okay, so you can do it kind of that way. Something that's interesting that people saw in class is, notice if I did this and then went from here to here, so the scale factor from here to here is, well, this is going from side length 2 to side length 2 square roots of 2. So you have to multiply by square root of 2. So notice that's kind of cool. If I multiply by 2 and then I multiply by square root of 2, that's the same as multiplying by 2 square roots of 2. And now watch this one here. If I go from this one to this one, well, that's doubling. Notice here, the side that's 2 becomes 4. The side that's square root of 2 becomes 2 square root of 2. So this has scale factor 2. And again, kind of look at this, scale factor square root of 2, and then by 2, you get the same as 2 square roots of 2. So this is Math 304. So I got a little bit muddled in class, so I thought I'd make this video that's a little bit cleaner, and you can actually have the numbers when you're doing with the tanagrams. You don't have nice assigned numbers like starting out with a 1, 1 square root of 2 triangle. Okay.